Let's get started on your day 2 notes over regressions and curve fitting. Today, we are going to be adding exponential regressions to the mix. So we've already done a linear regression, a quadratic regression on our calculator, and now we're going to add an exponential model. So here are your instructions for you to have, for you to refer to whenever you are trying to perform a regression on your TI-83 or 84 calculator. And I'll be walking you through the steps. So let's move on to example number 1. Example number 1 says bacteria was grown in a petri dish over a 24-hour period. The number of bacteria after X hours is recorded in the table below. We're going to be using our calculator to find the exponential equation that will best fit the data. Then we're going to find the value of r squared, and we're going to use this regression equation, the equation that our calculator comes up with, to predict the number of bacteria in the petri dish after 4 hours. So grab your calculator and let's get started.
I'm going to take the data from this table and I'm going to plug it into my calculator. So I'm going to go to Stat and Edit. And as you can see, I've already got the data from the table entered into my calculator. All of the hours, those are my X values, those are in L1. The number of bacteria, those are my Y values, those are in L2. So if you want to pause the video and plug these into your calculator, go ahead and do that now. The next thing we're going to do is we're going to turn on our stat diagnostics. And that will tell us the value of r squared whenever we perform our exponential regression, which will tell us how well that equation fits the data that we've plugged into our calculator. So I'm going to go to Mode, and then I'm going to scroll all the way down to Stat Diagnostics. And as you can see, I've already got mine highlighted. It's not off. If it's not highlighted, scroll over to On and click Enter. And then you can click Second Mode, and that will exit out of that screen. Now we're going to find our regression equation. So we're going to Stat. We're going to tell our calculator to calculate it. So I'm going to scroll over to Calc. And then I'm going to scroll down. And as you can see, number 4 is your linear regression, which we've worked with. 5 is your quadratic regression, which we've worked with. If you scroll all the way down to 0, that is where you'll find the exponential regression, which is what we are asked to find. So I'm going to press Enter. And then we're just making sure our L1 values are X values, L2 are Y values. We're going to scroll down to Calculate and press Enter. And as you can see, here we have our A value. Remember the equation, our exponential equation, A times B to the power of X. Our equation, if we round to 2 places after the decimal, the nearest hundredth, we're going to get 10.16 times B, which is times 1.57 raised to the power of X. That's what you'll write in A. B, the value of r squared, is 0.95. And that tells us that this equation fits our data. It's a strong fit for our data, which means it will predict, it is a good way to predict the Y values for this data. Okay, it has good dependent variable predictability. So now part C says use the regression equation to predict the number of bacteria in the petri dish after 4 hours. So we're wanting to know what is the value of Y when X is 4. We are going to interpolate this, right? Because 4 is within our data set, right? If I go to Stat, Edit, and I look at my table of values, 4 is between 0 and 12 in my X value. So we are interpolating here. I'm going to go back to my home screen, second quit, and I'm going to plug this in. 10.16 times 1.57 raised to the power of, I'm going to do this little caret, 4. And then press Enter. And there's your answer, 61.73. That is the number of bacteria in our petri dish after 4 hours, 61.73.
We've just finished example number 1 on our calculator, and I've filled in all of the answers for parts A, B, and C, so you can make sure that you have written all of your answers down correctly. We've got our equation right here. It's an approximation because I did round the decimals. We've got our value of r squared. It is an approximation, right? That's why I use the squiggly. It's a squiggly equal sign instead of just regular equal sign. So that's approximate. R squared is approximately 0.95. I rounded it. And then we use that equation to predict the bacteria in the petri dish after 4 hours. So I plugged in 4 for X right here, which is approximately 61.73, and I rounded to 62. Let's move on to our next example. I do want to point out in your packet, you do have directions for how to find a regression equation in Desmos if you're using that online. But this, we're just focusing on the TI-83 or 84 calculator. And now we're going to work through example number 2, where we are choosing the best model. Number 2 says, Michael put money in an investment account. The table below shows the value of the investment each year over a 5-year period. That is not a 5-year period. That is a 12-year period. So I'm going to have to change that. That should say over a 12-year period. So we're going to use our calculator to plug in this data into our calculator. We're going to, and I'm going to highlight some stuff here. We're going to perform a linear, quadratic, and an exponential regression for the data. Figure out which one best fits our data. Write that equation down. We're going to write the equation of r squared. Then we're going to make some predictions. We're going to predict the amount in the account after 20 years. And then we're going to figure out how many years it will take for the account to have a value of $3,000. So grab your calculator and let's get started.
I'm going to plug this data into my calculator. So I'm going to go to Stat and Edit. And as you can see, I've already got this data plugged into my calculator. I've got the years since the investment in L1. Those are X values. The value of the account in dollars, I've got those in L2. Those are our Y values. So if you want to pause the screen or pause the video, and then you can plug these values into your calculator. We want to make sure that your stat diagnostics are on. So go to Mode and scroll all the way down here to Stat Diagnostics. And if yours is highlighted off, arrow to the right and make sure On is highlighted and press Enter. And now we're going to, because we need to choose the model that best fits our data, we're going to perform a linear, quadratic, and an exponential regression. But what I do want you to see is I want you to see what this looks like on your screen. So we're going to, if you go to Graph, what do you see? You don't see anything. We have not turned our stat plots on. So go to Second, Y equals. We want to turn our plots on so that it will plot this data set on our graph. So press Enter and make sure On is highlighted. Press Enter again. And now you can go to Graph. Still see nothing. Well, if you look at your data set, you can see that your X values range from 0 to 12, and your Y values range from 600 to 1,138. So I need to change some numbers in my window. In my window, I'm going to make my X minimum -2, right? The smallest X value was 0. So an X value of -2, I would be able to see that X value. X maximum, let's make it 14. Okay, because that X maximum was 12. We're going to count by ones. My Y minimum, let's make it 500 because my smallest Y value is 600. And then my Y maximum, let's make it 1200. And then my scale, I don't want to count by ones. Let's count by 50. And now let's graph. So setting up your window is challenging for a lot of students. So it's pretty challenging. Okay, so as you can see here, here's my data. Here's what it looks like. Oh, that's kind of difficult. We've kind of zoomed in. Is it going to be a line of best fit or a curve of best fit? What's the best regression for this set of data that could predict, that would give me good predictability? So let's perform our regression. So stat, I'm going to go to calc, and let's find our linear regression first. Number 4, I'm going to scroll down to calculate, press enter, and whoa, that's a really good fit. So here's my slope, 44.86. My y-intercept is 578.22, and r squared is 0.992. So you can write that down if you want, but I'm going to go ahead and we're going to find our quadratic regression. We're looking for the r squared value that is the highest. 0.992, that's going to be hard to beat, but let's try. Stat, scroll over to calc. I'm going to go down to quadreg. We're going to do a quadratic regression for this set of data. And I'm going to scroll down to calculate. And here is my equation for my quadratic regression. I've got my A, B, and C values, and whoa, I have an r squared value that's pretty much 1, 0.99996. That's pretty much 1. That's closer than our linear regression. So as of right now, our quadratic regression would be the equation that would best fit the data. But now let's do an exponential regression. So I'm going to go to stat, calc, and I'm going to scroll down to exponential regression, which I know is number 0. So I'm going to press 0. I can enter or arrow all the way down to calculate. Press enter. And here are the values of A and B for my exponential regression. And my r squared value is very high as well, 0.9998. But if you recall, our quadratic regression, our r squared value is the highest. However, all of these are good equations for this data set. So let's go back to stat and calc, and I'm going to go to quadreg, enter all the way down. And here's my equation for my quadratic regression. I've got 1.12 x squared plus 31.35 x plus 599.84. My r squared value is approximately 1, or you could write 0.99996. Now, the part C says use the regression equation to predict the amount in the account after 20 years. So I'm going to do something here. I can go back to my home screen and I can type in my equation, and instead of x, like the variable, I can replace x with 20. And I can do that. And we did that in yesterday's video. What I'm going to do is I'm going to store this equation into y1. So I'm going to go to stat, and I'm going to calc again. And I'm going to do a quadratic regression, which is number 5. And I'm going to store this regression equation. If you don't want to do this, you can take that equation that we just found and you can type it into y1. So go to y equals and type in that equation. But I'm going to tell my calculator to store it. So I'm going to go to vars, y vars, scroll over to the right, press enter for function, and then press enter for y1. So I'm telling my calculator to find this regression equation and then store it into y1. And now I'm going to calculate it. There's my equation. And if you go to y equals now, can I click it? That equation is already stored in there and there's no rounding, or it goes out really far before it's going to round it. So there's my equation. And if you graph it, you can see it will plot it. And it's a really good predictor. Look, it pretty much goes all through all those points. So now we are asked to predict the amount in the account after 20 years. So we're extrapolating here. So I'm going to go to second table, and I'm going to find the y value when x is 20. I'm going to scroll all the way down to when x is 20. And up, 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 and we'll keep going. And we've got, oh, I arrowed down too much. Oh, it's right there. It's right there. $1,676.70 right here. $1,076.70. And if you used your equation where you rounded, you were off by a few cents, 1,674 and 84 cents. And I'm sure your teacher, I would take either of those answers. So now part D says, in approximately how many years will the account have a value of 3,000? So now we're looking for what is the X value when the Y value is 3,000. There's a couple of ways you can do this. What I would suggest doing is go to Y2 and type in 3,000. And as you can see, if I graph it, I have not gone high enough to be able to see this point of intersection. But if I go to zoom fit, so scroll down all the way to see where zoom fit is. And whenever you know where zoom fit is, I think this is a good place to start. It's number 0, then you could just press 0. We'll press enter. And it'll graph it. And there we go. Whatever scale it's given us, but it is going to fit this into, oh, it won't. Okay, well, let's do it ourselves. So now let's go to window and let's make our Y maximum, instead of 3,000, let's make it like 3,500. And let's count by 500. And let's make our X maximum something like 40, because I don't know what it's going to end up being. And now let's graph it. Okay, so now what we've like basically made our window bigger so that we can see further to the right and further up. And yes, we do see that point of intersection. Awesome. So now I need to find that point of intersection, because where this line, this Y equals 3,000, this is the point right here in which the Y value is 3,000. So what is that X value? So we're going to calculate the point of intersection. Now that we're in our graph, I'm going to go to calc, right? Whenever we're in our graph, we're up here, these top buttons up here. So second trace, that'll go to calc. And I'm going to find the point of intersection. So I'm going to scroll down to number 5, press enter, and then you can get it as close as you want to that, you can move it, but you can also just press enter 3 times. And that will tell you your point of intersection. It's 34.31, which is approximately 34 years. So in approximately 34 years, this account will have a value of 3,000 if this equation fits our data the way it says it does, right? So it should be a good measure of predictability. But obviously there are many factors that could go into this, but that's what you can write down.
We've just used our calculator to figure out all of this information, and I want to make sure that you have written it down correctly. So we have chosen that our quadratic regression is the best model to fit our data. I'm going to change colors here. Quadratic model is the best one that fits our data. Here is the regression equation. We've rounded it right here. We've even rounded the r² value to approximately 1. It's almost perfect. And then we're using that rounded equation, we're up here, the approximate equation, to find the amount in the account after 20 years. Now, if you stored that equation into Y1, and so you didn't round it, you stored it in there, you got like $1,674 and like 70 something cents. So that might look a little different right there, and that's okay. And then when we found at about 34 years, this account will have a value of 3,000. So in about 34 years, let's move on to our last example, example number 3. Example number 3 says, The results of a study comparing the speed of a car with its gas mileage in miles per gallon is shown in the table below. We are going to perform a linear, quadratic, and exponential regression, and we're going to determine which model best fits the data. We're going to write that equation down that best fits it and the value of r squared. And then the whole reason we do this is we're going to use that regression equation to predict the speed at which the miles per gallon is the greatest. So grab your calculator and let's get started.
I'm going to plug in this information into my table in this last example. So I'm going to go to Stat and Edit, so Enter. And as you can see, I've already got everything plugged in here. Speed in miles per hour, those are in L1, those are X values. Our gas mileage or miles per gallon is in L2, those are our Y values. And again, we're going to make sure we have just as many Y values as we do X values. You can pause the video if you want to plug that into your calculator now. I also want to make sure that I've got my stat diagnostics on. This is going to give me that value of r squared, or that coefficient of determination, which tells me how well my equation fits our data. And the equation for the curve of best fit will have the highest value of r squared. It'll be the closest to 1. So down here, stat diagnostics, if yours is highlighted off, make sure it's highlighted on. And now we're going to perform our regression equations. But you know what? I kind of want to see what this looks like on my graph. And again, if you go to your graph, we're given this window. We need to do a few things to see this data plotted on our screen. The first thing I need to do is go into stat plots. So second y equals, and I want to turn those on. We're telling our calculator that we want our calculator to plot those points. So on, it's going to plot a bunch of dots. L1 are X values, L2 are Y values. You know, this is what it looks like on my screen. It's probably slightly different on your screen. But now if you go back to graph, we still can't see it. We can't see it because we need to change our window. So let's go back to our table, and we see that our smallest X value is 10 and the highest X value is 80. So let's go ahead and change that first. Let's make our smallest X value 0 and our highest X value 100. So we're making sure that we can see everything in there. And our scale, let's not count by ones, let's count by tens. And what this does, when I go to my graph, is you can see those lines, they're not like, it doesn't look like one thick line right there, right? We're counting by tens, not ones. Okay, and we still can't see anything. So now let's go back to our table, and our Y values range from our smallest Y value is 15.7 and our highest Y value is 28. So if you go into your window again, we do not have a high enough Y value to see all these points plotted. But let's make our Y minimum 0. So we're staying in quadrant 1. And our Y maximum, that highest one was 28. Let's make it 30. And instead of counting by ones, let's count by twos. Why not? Or heck, let's count by fives. Why not? And now let's graph. Oh, okay. So there's what our data looks like. What do you think? What type of equation do you think would best fit this data? I'm seeing a quadratic would probably best fit this data. But let's do each one, our linear, quadratic, and exponential. So I'm going to go into stat. I'm going to go over to calc. And I'm going to go down to linear regression. That's number 4. Enter all the way down. And there's my equation for my linear regression. My r squared value is 0.22, which is a terrible value for r squared for an equation of best fit. I'm thinking this will not be our equation of best fit. Now let's do our quadratic regression. So stat, we'll go over to calc, go down to quad reg, that's number 5. Enter all the way down. And my r squared value is 0.889 or 0.89 if I wanted to round. That's a pretty high r squared value. I know we've had some r squared values that are like really close, but that's still pretty high. And right now it's better than our linear regression. So now let's go into stat, calc, and let's do our exponential regression. You can scroll all the way down, or if you recall, that's number 0. We're doing an exponential regression, and I'm going to calculate this. And as you can see, I have an R-squared value. Like my linear regression, that's pretty low. So we know that our quadratic equation is the equation that best fits this data. So I'm actually going to run that regression again. So stat, calc, and I'm going to do my quadratic regression, which is number 5. And just because I like to do this, I'm going to store this equation into y1. So vars, y vars, I'm going to store it as a function in y1. So now I'm telling my calculator to do all this. If you have an 83, you cannot store this regression equation into y1. And now we're going to calculate it. So there is my equation. I've got negative 0.007, if I wanted to round, x squared plus 0.67x plus 9.3. And there would be my equation. If you wanted to round it and plug it into y equals, that's what you could do. So my r squared value is 0.89. And now let's get to, we're going to use this regression equation to determine the speed at which the miles per gallon is the greatest. Well, if I graph this, remember, I've got it stored into y1. So if yours is not graphing this equation right here, this parabola, you need to go into y equals and you need to type in that regression equation. So it's not a perfect fit, right? Because this was just a scatter plot of some data, and we're using this equation to predict the speed at which the miles per gallon is the greatest. Well, our miles per gallon, those are our y values. It's the greatest at my vertex. So let's find that vertex. Let's find that maximum value. We're in our calculator, or we're in our graph, so we're staying in these buttons up here that are near the window, the screen. So second, trace, and I'm going to calculate the maximum. So I'm going to scroll down to maximum, press enter. So here we need a left bound and a right bound. I like to get where I think the maximum is, and I'm going to go I'm going to set my boundary maybe like right there to the left. And my right boundary, now I do the right boundary, I'm going to go over here just to make sure I've got a good boundary. There we go. So there's my bounds or boundaries. And then I'm going to go right here somewhere. And right in here are my guesses. So I'm going to press enter somewhere in between those two boundaries. And there is what I get. So my y value at 25.76, that's my maximum miles per gallon. The speed at which I get that is 49.29. Now, if you rounded, then your values are slightly different. Like I stored in this equation, but if I rounded it to negative 0.007x squared plus 0.67x plus 9.3, which is what I did on my answer key and what I'll write on the screen next, I got 47.86 as an X value, which is still very close. That's approximately 48 miles per hour, and this is 49. So that's pretty close. So it's approximately 48 or 49 miles per hour at which the miles per gallon is the greatest. So now let's fill in your notes.
We've just used our calculator to figure out all of this information, and I filled it in to make sure that you've got it filled in your notes correctly. And as you can see, we are using, here, let me change colors here. Purple will be good. We used our quadratic regression. We approximated our equation. So y is approximately, so here are your rounded decimals, negative 0.007x squared plus 0.67x plus 9.3. The r squared value was rounded to 0.89. Using this rounded equation up here, here's the decimal you would get for that vertex. On the video, I stored it into y1, and so we got a slightly different x value there and y value for our vertex. We rounded it to 49 miles per hour, and that's fine, right? But I'm on here, I want to show you that if we use that rounded equation, we'll get something slightly different. So you just need to always make sure that you're following the directions, whatever it says. Approximately 48 miles per hour. If you wrote 49 miles per hour, that the miles per gallon is the greatest, that's fine too. And that concludes your day 2 notes over regressions and curve fitting. Today we focused on linear, quadratic, and exponential models. I hope it was helpful.